Hello and welcome to lesson 4 of the statistical analysis unit. Today we are going to be looking at outliers. So outliers in a set of data are pieces of data that are really far away from the rest of the data in the group. So a really high outlier could be someone who's very tall compared to everyone else in the class. A low outlier could be someone with a lower test result. Or you could be looking at things like really high prices, babies that are perhaps born with low weights. Obviously, that might be something hospitals want to identify and put different care plans in for. And usually what we've done previously is given you a list of numbers or perhaps a graph and just said from this list of numbers, which ones are outliers? And we're kind of expecting you to pick it out by eye, just kind of, well, what number looks like it's really big or which number looks like they're too small. That's not mathematically great, just kind of the idea of what something looks like, a little bit of guesswork, your own intuition. That's not something that is reliable from one person to another. So instead, what we're going to use now is a mathematical definition, which is this second paragraph. What we're going to do is say that any outlier is either going to be one of two things. It's either going to be more than 1.5 times the interquartile range above the upper quartile, so that's a high outlier, or any score that's less than 1.5 times the interquartile range below the lower quartile, so a low outlier. How do we write this mathematically? Well, that's this line here. So the outlier is greater than the third quartile plus 1.5 multiplied by the interquartile range, or an outlier is any number less than Q1 minus 1.5 times the interquartile range. So why do we want to identify them? Well, high outliers push the mean and sometimes the median up if there's enough of them. Low outliers push the mean and sometimes the median down. It's not often that they have an effect on the mode because they're not usually grouped with other high particular numbers, but sometimes it may happen, very rarely though. So because outliers can drastically affect the mean, it can be that when we present the mean as a statistic to give a good idea of a measure of central tendency, it's too high or too low, depending on what that outlier was. So if you think about the property market, especially in the big cities, Melbourne, Sydney, there are often some homes that are sold for really crazy high amounts of money, in many millions of dollars. But when people are sort of thinking about the average house that they want to buy, they're not too worried about those big, massive houses. They don't want prices to be taken into account. So when you watch the ABC or read newspapers, you'll often see them actually report the median house prices for these very reasons. So the median is less affected by these outliers, which makes it easier for people to understand the average price. But the house price of the big ones, they do still count. They are still in the list. They don't have to be removed for it. Okay, so let's test those calculations on the next slide. So on the next slide, we are going to consider the A-League team scores that we had before. It was the list of 10 teams and the number of points they had by the end of the 2017-2018 season. What we determined was that their interquartile range was 11. The lower quartile was 32. And the upper quartile was 43. Now, Sydney FC came top with 64. The Central Coast Mariners came bottom with 20. Newcastle Jets came second. They were pretty close, not at the top or bottom, so we're not going to worry about them. And we just want to check quickly, were either of those outliers? So basically, we're checking that Sydney FC mathematically were an amazing team who sort of came really far away from the rest of the teams, and were Central Coast Mariners a really bad team? Were they really poor mathematically, not just in terms of their results? So let's check. Let's do those two outlier equations. So we are going to check the high outlier first, and we are going to say that the outlier will be greater than or equal to Q3, 43, plus 1.5 times by the interquartile range of 11. Work this out. And what you'll find is that the outlier, I'm just going to use out is greater than or equal to 59.5. So any score, any total amount of points at the end of season that was greater than 59.5 would count as an outlier. So 64 is greater than 59.5. So the conclusion is Sydney, they are an outlier. So mathematically, Sydney FC were much better than all the other teams over the course of that season last year. They didn't win the overall cup, so they may feel a little bit hard done by. Okay, let's test the other one. The other outlier is anything that is less than or equal to the lower quartile, 32, minus 1.5 times by the interquartile range. Once again, we put that into a calculator to work it out, and we get that it's 15.5. Sorry, tablet got that wrong. So anything that is less than 15.5. Well, 20 is greater than 15.5. It's not less than or equal to it. So the Central Coast Mariners are not an outlier. So they came bottom, they didn't do very well, but mathematically they weren't a huge distance away from the other teams in the group. I don't think that would be much comfort to them, but there we go. That's it. That's how you check for outliers and how you should set it out, just with these equality signs. Hopefully that makes sense. What you'll need to do in class is exercise 10E. Questions may vary depending on what your teacher recommends. And if you've got any questions, then do ask them.